Good morning, everyone. Welcoming you all to the 6-day internship session with 10B EduPro. So today we have our trainer, Mr. Sanjay Goswami. He has 3 years of technical experience at Accenture and he is currently pursuing a PhD at NIT Silchar. So now I am welcoming Mr. Goswami and requesting him to please start today's session. Uh, Sanjay Goswami, are you there?
Yeah, thank you, Ria. So, hello everyone, good morning. Am I audible?
Yes, sir.
Okay. There's 32 participants, so we can wait for 2 minutes. After that, we'll start. Okay, is it visible?
Yes, sir.
Okay. Okay, so let's start. Have anyone know about supervised learning? Have anyone heard about it earlier? Am I audible?
Yes, sir.
Okay. Okay, so let's start. Supervised learning. So supervised learning in machine learning, it's a critical technique in machine learning language. Okay. So it involves training models. Okay. Training models on label dataset. So what do you mean by training? Training means, in a simple term, training means what? Anyone? Just wait a minute. So
Sir, process of learning
yeah.
or developing skills.
Yes, training in simple term, it is like to
Term
train
to
something. Like yeah, yeah.
to prepare something
What?
or
Yeah.
to prepare something for a particular task.
Okay. Yes, to train something, right?
Yes, sir.
Yeah. So that means training. Yeah, on a label dataset. So do you know what is a label? Label means something which is they are in like orange and apple. If we name them orange and apple, then the names are called labels. Okay. So it is the process of training models in label dataset in the simple term. And these are the overview of supervised learning. The definition: supervised learning involves training a model on label dataset where the outcome is known to predict future outcomes or new data. Okay. So where we can apply supervised learning, we can apply it widely used in various fields such as finance, healthcare, and marketing. So how we can use it in finance? Can anyone give me any example? Or in healthcare? Like how can we predict a disease? We can predict a disease through its symptoms, right? So if some symptoms are present, then we can predict the disease. So it can be done through supervised learning. Okay. And then there are two types of supervised learning. One is classification and another one is regression. Okay. We'll know about classification and regression in the next slides. Okay. Next, this is the classification overview. In the definition, we have the classification is a type of supervised learning where the goal is to predict a discrete label for an input based on the features. So it is like the data set have some values. So have you know about what is a data set? Do you know about it? Anyone know about what is a data set? Okay, so we will see it. In an example, in an example of classification, like what is a classification? Like we can classify between spam and not spam. In an email, you have received many emails, right? So some of them are classified as spam emails. So how we can classify them? We can classify it through supervised machine learning algorithms. Okay, so some algorithms are like decision tree, random forest, and support vector machine. These are some example of supervised machine learning for classification. Okay, so this is a definition of classification. Classification is a crucial aspect of supervised learning, focused on accessing discrete levels to input data based on its features. In this process, we train a model using a level dataset where each input sample is paired with a known output level. Okay. This allows the model to learn patterns and relationships within the dataset, enabling it to predict the category of new and unseen data. Okay. The key concept of classifications are input features, labels, and model training. So what we have in input features, these are the attributes or characteristics of the data used for prediction. Okay. So we'll see all of this in a data set. So here is a data set. Okay, here is a data set for supervised machine learning. It's a label data. So here you can see every data has its label. Okay, this is study hour per week. This is attendance rate. This is past exam scores, that is they have got in earlier exams. This is the final exam score. This is one that means it's the current exam score. Okay, and pass fail, whether the student get passed or fail. So the criteria is that the final score has to be above 60. Then it will consider that as pass. If the score is below 60, then it will consider as fail. Okay. And this final score is predicted through the earlier attributes. Okay, these are the attributes. And this is the class level, pass or fail. These are the class levels. That is why this process is called labeled. Where is the supervised machine learning? Labeled dataset. That means the classes has its levels. Okay. If we not consider the pass fail this column, then these are the unlabeled dataset. Okay. Okay, let's. What are the input features here? This study hour per week, attendance rate, past exam score, and final exam score. These are the input levels. Okay, and this is the final output column. Okay, if a student study 31 hours per week with an attendance rate of 68 and past exam score 86 and the final exam score is 63, then the student will pass the exam. So this is the concept here. Okay. So anyone have any doubt till now? You can ask if you have any doubt or any question. Just feel free to ask. Okay. No, fine. So what is model training now? So what we'll do from here, it will consider these input features and the model will be trained on the input features. These are the input features, right? And it tries to predict whether the student will pass or fail. This is the training process. Okay. After that, okay. So here you can see there are only two classes, right? Pass or fail. There are two classes. So do you know what is binary? What is binary? What do you mean by binary? Can anyone tell me? You heard about it, right?
So 0 and 1.
Yes. So you have heard about it earlier, or you might heard about unary, binary, ternary. Yes.
Yes, sir.
So what is unary?
So it means only one output,
Yes. And what is binary then? It has
double output. It has
two
two
outputs.
output.
Yeah. And ternary means three output.
Yeah.
Okay. So here the binary word means two outputs. Okay. Okay. So here you can see that there are two classes, pass or fail. So this classification will useful for for two classes. If the dataset has two classes only, then the binary classification will work. So binary classification refers to unique type of classification task in machine learning where their outcomes are limited to just two distinct classes. Okay, such as yes or no, spam or not spam. Fine. And the examples are, for instance, a practical application for binary classification is predicting if the patient is likely to have specific disease based solely on the results of various medical tests, yielding a clear yes or no outcome. So we can take an example from this dataset. Okay, this example dataset. So here we have only two classes, pass or fail. So according to this, after training the models, the model will predict between the two classes. It will either predict pass or predict fail. Fine. Anyone having any doubt? If you are not understanding, you can ask me, okay? And feel free to ask. It's fine, okay? So some evaluation metrics are there. After this training process, we will test the model. Okay. This is actually everything is going on through mathematical functions. It depends on the mathematical functions, and it will take out the pattern and relationship between these this independent classes. Okay, these are called independent columns, and this is the dependent column because the pass will depend on these all of these columns, right? So there are multiple evaluation matrices, performance based on classification. Several important metrics such as accuracy, precision, recall, and F1 score. These are the evaluation metrics. We'll see what are these after the when we will do our practical session. We'll see about this. Okay. So here is the if there are more than one classes, then it will called multi-class classification, right? It is simple, right? Binary classification and multi-class classification. Okay. Binary means two, multi-class means more than two. Okay. Multi-class classification involves predicting one level from three or more classes. Okay. That means we'll see it after if we have to know. Okay. For example, and can you give any example for multi-class classification? Which having two or more classes?
So cars.
Yeah, cars. I was thinking about that. Very good. So if we can, if we want to classify between two or three, more than two cars, like we have Safari, we take out only Tata, okay? So we have Safari, we have what? Nexon, okay? We have Indica, right? So these are categories, some different from each other. So we can classify between them through multi-class classification. Okay, we will analyze the picture of each car, and it will predict which one is comes under which class. Fine. This is an example. So this is the technique of handling multi-class classification, one versus rest, and softmax regression. So this softmax regression will not cover this in this session. We can understand this one versus rest. Like if we consider only one class, like we'll consider Safari, for example, then the other comes under one class. Okay. Then we can differentiate between them. Fine. So next we covered the classification part, then we'll have the regression part. Okay, in definition we have regression analysis explores relationship between variables. Okay, and what is regression? So if we have, yeah, okay, this is the data set. Okay, fine. In application where we can apply it, it predicts outcomes based on input variables. So basically regression means continuous data. Okay. It will predict continuous values. Fine. We'll see in the dataset. So regression analysis is a powerful statistical method used to understand the relationship between variables. In the context of this presentation, we'll explore how regression helps in predicting continuous outcomes based on various inputs. Okay. So purpose of regression, it aims to establish a mathematical relationship where one variable can predict the value of another, making it essential in fields ranging from financial to healthcare, and we can use it in many other fields. Okay. Types of regression. We have multiple types of regressions like linear regression, multiple regression. Okay. Polynomial reads. These are different types of regressions. Okay. And okay, so we'll understand it regression from this small data set. So this is the same data set. The pass-fail column is not here. So like from these three columns, we can predict this score. Okay, this is called regression. There must be some what we'll call it, like relationship. Okay, in these three columns there must be a relationship between them. So the regression algorithm finds that relation, finds that pattern to predict this score. Okay, it predicts the score. So if you wants to take out your score, like wants to know your final exam score, so you can predict, you can give the data like how many hours you studied per week, right? And what is your attendance rate, and what was the past exam score. Then you might be able to know your final exam score or the next upcoming exam score, right? So this is called regression. It will produce the continuous values. The algorithm will train on this dataset, and after that, any new values if come, then it will predict this code. So do you understand?
Yes, sir.
Okay, only one is replying. So anyone else?
Yes, sir.
Visalsa. Okay. Okay, well, if you are not able to understand, then please tell me, right? We might have the test that doesn't know. Okay. So next we have supervised learning algorithm overview. Okay. So these are some different algorithms for different purposes. This linear regression is for regression. Okay. For to predict the continuous value, we will use linear regression. Fine. This technique widely explored to predict outcomes, continuous outcomes. Fine. And effective modeling a linear relationship between independent and dependent variables. So here, these three are independent variables and These are the dependence variables. Okay. This final exam score is a dependent and depends on what? Past exam score, attendance rate, and study hours per week. Fine. Okay. So then we have the logistic regression. It is used for classification purpose. Though it have the regression in its name, but it is used for classification. Fine. Logistic regression is a supervised learning algorithm used to predict the probability of a binary outcome using a logistic function, sigmoid function. Have you heard about sigmoid function? You might have in your mathematics. Do you remember it?
No, sir.
No. Okay, so sigmoid is a function which gives the probability. Okay, like 0 or 1. It gives 0 or 1 value. It depends on, it does the differentiation. Okay, so this is a completely, this part is completely comes under mathematics. So you have to actually go through deeply in this each of these algorithms. There are a lot more algorithms are there. So it is not possible to cover all the algorithms here and to explain everything about it. So you have to go to afterwards. You go to the. You can use YouTube also. You can learn from there. But here we can explain how we use these algorithms, and it is a overview kind of session. Okay. Okay, here we have decision tree. You might have heard about decision tree earlier. Okay, this thing is similar to if-else function. Have you covered if-else?
Yes, sir.
Okay, so what is the if-else? Can you tell me?
Sir,
Do you
if
remember it?
the
Yeah.
condition is true, then the if part will be executed, and if the
Yes.
condition is false, the else part will be executed.
Yes. Very good. So this decision tree, actually the decision part is the condition. Okay. If the condition is true, then it will falls under the yes part. And if the condition is not true, then it go to the no part. Okay. It utilizes branching structures. So there will be like multiple branches if else, then there will another condition is there, and then it will comes like, and it will creates a tree-like structure. Okay, every node has a decision mathematical function is there. It will calculate whether the input goes to the if yes or no. Okay, it is similar to the if-else statement. Okay, then random forest. The random forest is a combination or a collection of decision trees. Fine. There will be multiple decision trees simultaneously running, and after that it will predict some values in the random forest classifier. Okay. So any doubts till now? No? Fine. Next we have data preprocessing. Okay, have you covered data preprocessing earlier in like day 2, day 3 sessions?
Yes, sir.
Okay, you know about it? Anyone can tell me what you have learned? Just simply tell me what is data preprocessing.
It means to remove noisy data, etc., or to
Yeah.
organize data.
Okay. Yes. So, and it will also used to deal with empty values, right? So data preprocessing is a crucial as it prepares the raw data for analysis. Okay, raw data may have multiple issues. It may have null values or empty values, or I mean empty cells, and it may have some noisy values. Noise means what? Some error making values. Like if there is a data set of adult people and there is a person which age is 17.5, okay, or 17 years, then the 17 years person will be what? Like that data is a noisy data. We'll consider it as noise. Okay. And there is outliers also, but sometimes outliers. Do you know about what is noise and outliers? No, right? Okay, I guess no. So noise is something which I have said, like if the data set having only adult people and one person having age below 18, then that person will be the noise, okay, inside the data. If the whole data set having people aging from 18 to 25 and one person is there with a like age, who is Zoom user? I'm just admitted. Okay. If the data set having people with age ranging from 18 to 25 only, and one person is there which having the age of 60 years. Okay. So this 60-year person will be adult, right? But he is inside the data set which having only 18 to 25 years peoples. Fine. So that 60 years person will be the outlier. Okay. Have you got the concept?
Yes, sir.
Noise and outlier. Noise means error. Okay. An outlier is not an error, but it is something which is possible but rare. Fine. Which is I think the age group is from 18 to 25 and 60 years is also the adult person. Okay. So we'll try to reduce the noise in this data preprocessing part. Okay. And common techniques includes handling missing values. Okay. And encoding categorical variables. We'll do this in the practical session. And normalizing numerical features. Okay. These techniques, this is the one of the most important part of any machine learning, deep learning, or anything where you are trying to do some predictions or do some classifications, regressions, anything. So this data preparation part will be there, and this is crucial for a good model or a good training model. Okay. So in example, we have already discussed like categorical variables, numerical format. So one hot encoding is there. So what, okay, you will not know. So one hot encoding, what is one hot encoding? It means if I consider 50 as 1 and rest of others as 0, then there will be in this this cell there will be 1, and in this cell there will be 1, and the others having 0 only. This is called one hot encoding. Okay, in simple term, this is called one hot encoding. So you can explore it more. Okay, you should go through all of these algorithms what I have told you today. Okay, so we'll move to the next part, that is scaling features. Scaling features means we have to actually the dataset should have equal number of classes. Like there are two classes, so the dataset should have equal number of just a second. Yeah, there is two classes, right? Pass and fail. So the dataset having equal number of independent variables for pass and equal number of independent variables for fail. So here if we'll calculate here, like pass, how many number of pass classes are there? 1, 2, 3, 4, 5, 6. There are 6 classes which are having pass values. Okay, and 3 classes which are having fail values. So this difference of pass and fail values will hampering the Imon Bora. Anyone know him, Imon Bora? Okay. So we have to do what? We have to balance these both classes. We have to balance the features of each class. There must be equal number of datasets for pass class and equal number of datasets for fail class. That is called scaling. Okay. We have to do it because it can hamper the training process, and it will resulting some bias values, or like the model will randomly pick any one class. Okay. Basically, it will generate some faulty values. So we have to do scaling. So feature scaling is the process of normalizing and standardizing the range of independent and dependent variables, independent variables or features. Okay. So independent variables means what? These are the independence variables, right? Study hour, attendance rate, and past exam score. So these variables should be equal in both the features, for both the classes. Okay. So there are methods for feature scaling. These methods are there are two most common methods: min max scaling and z-score normalizing. Okay. What is min max scaling? Like this is the maximum class, max class, right? Pass is the max class and fail is the minimum class. So we can do what? There are two aspects we can do. Like we can add more values to the fail class. Okay, we can add more like this data set. We can add more data set for fail class. There is a possibility, and there is another possibility. We can remove pass class. Okay, pass is the max class. We can remove 3 of pass class, 3 tuples, like three rows of this pass class. Then the fail and pass ratio will be same, right? Do you understand? Anyone?
Can you explain that again?
Okay. So min-max scaling means we have to balance the pass and fail number of rows. Okay. This is one row. Okay. This is one row. This is another row. This is another row. Right. So there are six rows which have pass as their class, right? And 3 rows having fail as their class. So we have to do like equal number of pass and fail classes. Fine. So we have to remove or add some new rows there. Okay.
Yes, sir.
Are you clear?
Yes, sir.
Okay. So we can remove or add. If we want to add some classes, then we will add in the fail group, right? If we'll remove some classes, then we will delete it from the maximum class. Okay, maximum classes pass and minimum classes fail, right?
Yes, sir.
Okay. So here's the importance of scaling. So proper scaling can significantly enhance the performance of algorithms like K-means and SVM. K-means we'll discuss in the next session, okay? In the unsupervised learning, and which are sensitive to the scale of input data. I have already told you what is the significance, like it can enhance the performance of any algorithm. Okay. And next we have essential techniques for feature separation. So here you have seen this is the entire dataset. Okay. Now, what is the training and what is the test dataset? We'll learn about it. Fine. So independent features, I have already told you what are the independent features. And the independent features are the various variables that act as vital input for the predictive model. Okay, playing a direct role in its capability to decipher the recognize underlying patterns within the data. So, okay, just wait. So these are the independent variables like study hours, attendance rate, past exam score, and final exam score. These are the independent classes for classification, like for binary classification. And this is what? Dependent class, right? This past, fail, these values are dependent on what? These 4 columns, right? So these are the independent and this is dependent. Fine. So here independent features means the features which are in the left side, we have 4 features, 4 independent features. Fine. These are the features like study hours, attendance rate, past exam score, and final exam score. These are the features. So these features are categorized as X. Okay. So here, this X means independent features and Y means dependent features. Fine. Do you understand that?
Yes, sir.
Okay. Here the dependent features or target. Target means what we want to get, that is target. And dependent features are the target. Okay. The target feature Y represents the dependent outcome variables that the model aims to predict. Fine. It relies significantly on the input data fed into the system. Fine. And these are the input data. Okay, these independent features are the input data which we will give to the algorithm to predict the dependent features. Okay, the Y features are the dependent features. We will give these as input, and we are expecting these are as outputs. Okay. Okay. And the third, we have importance of feature separation. Why we are doing this separation? Okay, this is important, right? Ensure a proper separation of features is crucial, as it facilitates effective and efficient learning from the dataset. Okay, and which is turn results in more accurate and reliable predictions. So it is the process, right? We are separating this input and output data The input data will go to the algorithm. The algorithm finds some patterns. Okay. Based on that patterns, it will predict, and then the evaluation functions will work. The accuracy will be measured. Fine. So we'll learn these things in the next sessions. Okay. Understanding the concept of okay, for data division and train test split. Here you have seen this train and test. Okay, test. Fine. So we'll understand that. This method entitles the partitioning the entire dataset into two distinct subsets, with one subset designed for training the model and the other reserved for accessing the overall performance of the real world situation. Okay. Good. And what is like purpose of train tests? The primary goal is to effectively evaluate how well the model generalizes the previously unseen data. Okay. And therefore preventing issues of the overfitting that can severely compromise the performance of the accuracy of a performance and accuracy. Okay. So these are the training. The whole entire data set is splitted into two parts. One is training data, okay, and another one is test data. This training data is used to train the data set, train the model. Okay, this training data is used to train the model, and this train Y features means it will compare the output that is generated through this using this input data set, the predicted output, and these are the actual outputs, right? So the model will compare the predicted outputs and these actual outputs, and if these are same, if the model correctly predicts the classes of correctly predicts the classes, then it is evaluated through this Y train. That means this Y dataset. Fine. And this is the test. These data are not seen by the algorithm. The algorithm will only can see this input data and this actual outputs, so that it can train itself. Fine. Do you understand this training part? Am I able to explain it properly?
Yes, sir.
If you are not able to understand, then I will try it again. Okay, so this train test split is done through like there's a ratio. That means it is a widely used ratio. Like from entire dataset, we will take 70% of it for training purpose, and we will use 30% of the dataset for testing purpose. Okay. However, this ratio can be adjusted based on factors. Okay. So here you, if you want to calculate, then there are 7 rows for train the dataset, and there are 3 rows for test the dataset. This is the 70-30 ratio. And I'm again explaining that this dataset, this training dataset is used to train the model, and this test dataset is used to evaluate the model, evaluate the outcomes of the model. Fine. The model will train on these datasets, and after that, when we will give this much information, 31, 51, 78, and 50, then it should predict the student will pass or fail, right? This is called test. Okay. Do you understand? Okay, we'll see it in the practical session. Fine. So do you have any doubts till now?
No, sir.
No, sir.
Okay. Okay, we'll understand properly during the practical session. Okay. So this is a model fit. That means how the supervised machine learning models are fitted in the fitted with the dataset. Fine. So model fit refers to how effectively a statistical model captures the described and underlying patterns of the data. It was trained on the data. That means it tries to capture the patterns and the relationship between the independent variables. Okay. Thereby reflecting its predictive accuracy. Okay. Some difference between overfitting and underfitting. These are some, these two are very important terms in machine learning. So overfitting and underfitting. A well-fitted, so what do you mean by overfitting? In a simple meaning, what is overfitting? What comes first in your mind when you heard overfitting? Anyone? Okay, overly fitting, that means the dataset, the model fitted overly. Okay, the model gets more features, right? There might be hundreds or thousands of features. So, and the model, if the model is so simple, it cannot capture the pattern from there, then it will called overfitting. Fine. And what is the underfitting? Underfitting means the model is quite complex, but the features are very limited. Then it is called underfitting. The importance of visualizing model fit. So graph comparing predictive values to actual values serves as powerful tools for visualizing the model's performance. Okay, we'll see this in the practical session. There are some graphs are there to evaluate the model, and thus we can have the visualize the model outcomes. Okay. So this is the concept of overfitting. Overfitting happens when a machine learning model becomes overly tuned to its training data. Okay. And memorizing specific patterns and noise instead of identifying the borders. General patterns that truly represent the data's underlying distribution. This excessive focus can yield misleading calculations about the data. Okay. I have already simplified the term overfitting. It means overly fitted features. Fine. If the model is very simple and there are too many features and it cannot get the right pattern and right relationship between the independent features or input features, then the model will be overfitted. Fine. An overfitting on model performance. As a result of overfitting, the model tends to perform poorly on new or unseen datasets. So what is new and unseen dataset? This test data, this is the unseen data. Okay, the model cannot see this data. Fine. This is the training data. The model can see it and it learns from these features. Okay, and try to predict the output. And these are the unseen data which is used to test the model. Okay, the model can predict correctly or not. This data set is used for that. Fine. So okay. Mitigating overfitting. So how we can mitigate the overfitting? To mitigate the risk of overfitting, several effective techniques can be employed. This includes pruning decision tree to reduce complexity, and applying regularization methods that add constraints to the model, and utilizing cross-validation. Okay, cross-validation means this entire data set separated in multiple parts, and it will test for each part. That is called cross-validation. Okay. To ensure that the model is tested on multiple datasets during training, thus improving the generalizability. Okay. So fine, we can learn more about it in the practical session. Okay. Here is the understanding of underfitting. Okay, what is underfitting? Underfitting occurs when the model is overly simplistic and failing to accommodate the complexity and underlying patterns present in the dataset. So when the model is fitting with less features, then it will going under underfitting. Fine. Symptoms of underfitting can be recognized by observing that both training and testing errors remain high, which signals that the model is ineffectively learning from the training data. Fine. So when the train accuracy, like the predicted value and actual value accuracy of that, and the test accuracy are both of them are low, then we can say that this goes to the underfitting. Okay. So how we can resolve this? To combat underfitting, one can increase the model's complexity, introduce additional features on the additional features, or reduce the regularization patterns parameters. Okay. Thereby allowing the model to learn more from the data. Fine. So understanding bias and variance. What due to underfitting and overfitting, there are two problems that occurs. That one is bias and another is variance. Bias in machine learning models, this error arises when we attempt to approximate a complex real-world problem, resulting in systematic prediction errors that consistently skew our results in a particular direction. That means the entire model becomes biased for one or two for one class. Like if we consider a binary classification problem, then the entire model, let's suppose the entire model biased for like pass class only. Okay, then the model will predict some fail values as pass category. Fine. That is called bias. Okay, variance. In machine learning models, variance means, what do you mean by variance? This is like a variance you can simply resemble with variety. Okay. If there are multiple, like if the data has more than 2-3 classes. Okay, and the model could not predict the class properly. Fine. This type of errors occurs then when a model becomes overly sensitive to small fluctuations in the training dataset. Fine. Which can ultimately lead to high, inconsistent, and unreliable predictions across different datasets. Okay, that means there are small variation in the training data. It will predict some different values. Okay, that means variance. It trains in very less data, so it take out the very small variance, small difference in the features. Okay. Trade-off between bias and variance. In the realm of supervised learning, efforts to reduce bias often results in an increase in variance, highlighting the critical balance that practitioners must maintain to achieve the best model performance. Fine. It means if the bias and variance are high, then the model will not work properly. It gives some error values. If the both bias and variance values are less, then the model will work properly. Fine. Do you have any doubt? Am I audible?
Yes, sir.
Yes, sir.
Okay, have you any doubt?
No, sir.
Okay. Then we'll move to the next, that measuring accuracy effectively. Okay. So we have to predict we have to check if the model is predicting the outputs properly or not. So there we have to calculate the accuracy. Fine. Accuracy defined as the ratio of the number of instances that are correctly predicted by a model to the total number of instances in the dataset. Okay. So instances means these are like instance. Every row is an instance in the dataset. Fine. So what it is telling, like, it predicts the ratio between predicted class, predicted value, the output value, and the actual value. Okay, actual class. So these measures is frequently employed in performance evaluation to gauge how well the model is performing relative to the actual outcomes. Okay, making it a crucial metric in various fields. So the accuracy can predict it, like this is the test dataset, right? So after the training the model with the training dataset, the test part will begin. In the test part, we'll give this row as an input, and the model will learn from this training data. Okay. So the model could predict some class. Okay, the model could predict some class from the learning. Okay, from their learning, it can predict any one class, and the accuracy will measure how many number of classes are correctly predicted. Fine. If the model correctly predicts this row as fail, okay, so then the accuracy will be 1. If the model could not correctly predict, then the accuracy will be little less. Okay. So this accuracy used for what? To evaluate the model, how the model predicts, how the model performing or can predict the class correctly or not. Fine. Accuracy limitations. So while accuracy serves as a very valuable metric for accessing model performance, its interpretative value can dismiss significantly in scenarios involving imbalanced dataset. So I've already told you about the scaling, right? So scaling is done, then the dataset will be balanced. Then this will be not an issue. Okay, where certain classes may dominate. Okay, that means if the dataset is imbalanced, then certain classes may dominate. But if we apply scaling, then this problem will not occur. In such cases, high accuracy could occur simply due to the majority class predictions. So this is the limitation of accuracy. If dataset is imbalanced, then it can give some high accuracy, but the results are not actually correct. Okay. Then other performance metrics are there. Addition to accuracy, other performance metrics such as precision, recall, and F1 score offer a more comprehensive and nuisance perspective on how model perform. Okay, we'll see this, we'll do this in the practical session, how we can calculate accuracy and along with the precision, recall, and F1 score. These are some performance metrics which evaluates the model. Okay. So other model evaluation techniques are there, like cross-validation. I have already told you how cross-validation done. The entire data set is separated in different parts. And after the training part, the model will re-evaluated through each part of the cross-validation. Okay. And confusion metrics. Do you know about metrics?
Yes, sir.
Okay. So this confusion matrix take out the truly positive. The model will separate them like positive and negative class. And if the positive class is predicted as true, then it will goes to the true positive, then true negative, and false positive and false negative. These are 4 parts. Here's we can see the true positive and true negative metrics. So here you can see this positive and negative class, and here this should be true and false. So this the confusion matrix is a crucial tool used to evaluate the performance of classification model. It provides a comprehensive view of the model's predictive capabilities by detailing true positive, true negative, false positive, and false negative. This breakdown allows for a clearer assessment of metrics like precision and recall. From this part, we can calculate the precision and recall, and all the other evaluation matrices. So what is true positive and true negative? So in the data set, if the model predicts, let us assume this pass is the positive class and fail is the negative class. Okay. If the model could predict the class correctly, then it will goes to the true positive. Okay. If the model could predict this second column, this second row as pass, and pass is a positive class, right? So if the model could predict the positive class correctly, then it will go to the true positive part. Okay. How many number of rows classified as true positive goes to the true positive. Okay. And this is the negative class, right? If the model correctly predicts the negative class, then it will go to the true negative. Fine. And if the model could not predict the positive class correctly, then it will go to the false positive. Okay. So this in this way, the true positive and false positive counts are calculated. Okay. Next, we have ROC curve. So this is another visualization technique which can predict which is useful to see the performance of the model. Okay. The reviewer operating characteristics, that means this receiver operating characteristics, that is ROC curve, is a graphical representation of a classifier's performance across various thresholds. Okay. Components. It plots the true positive rate against the false positive rate to visualizing the trade-off between sensitively and specifically. Okay. And AUC, that means area under the curve. This ROC generates a curve, and AUC is the area under the curve. Fine. These are actually visualization techniques. We'll do it in the practical session, then you will get understand well. Okay, so this quantifies the overall ability of the model to discriminate between classes with higher values, including better performance. Fine. AUC and ROC are used to visualize how the model is working and calculates its performance. Fine. So this is the final thought on supervised learning. Supervised learning is poised for significant advancements in growth, integration, and future trends. As the field evolve, it is crucial for practitioners to combine their expertise with machine learning to enhance model effectiveness and address emerging challenges. So the supervised machine learning can be used in multiple real-world problems. Fine. And it can be used for classification and regression purposes. So there are a lot of problems. Okay, there are a lot of problems in classification and regression. Fine, regression means continuous values. We can predict students' marks, and in other terms, like we can predict house rents. Fine, if the house is in a urban place, then what will be the price of it? It can predict that. So these are some and some disease can be predicted, right? So these are some real world problems. So supervised learning can give some solutions in these real world problems. Fine. So do you have any question? Anyone?
No, sir.
No?
So
Okay. So we'll stop now and we'll resume from 12. Okay, we'll do the practical part, and you'll do one thing. You'll bring like, have you coded in the Google Colab?
Yes, sir.
Yes, sir.
Okay, so we'll code in the Google Colab, and we'll there will be two or three programs. We'll do that and understand how the machine learning works. Okay, fine. Okay, join from the 12th, right? Okay, thank you. Okay, let's wait for 5 more minutes, then we'll start. Hello, am I audible?
Yes, sir.
Okay. Are you ready with your Google Colab?
Yes, sir.
Okay. Let's start. I'm sharing my screen. Is it visible?
Yes, sir.
Okay. So you do one thing, split screen, right?
Yes, sir.
Okay. Just click Windows plus left key, left arrow, so that you can split the screens. Are you here? Create one notebook, new notebook. So first we'll do binary classification. Okay. So I will share one data set with you. Just give me a minute. So I have shared this data set. You got this?
Yes, sir.
Okay. So download the data set first. Okay, so I have already explained this data set, right? Like this course and pass failed. Okay. So we'll work on this data set. Fine. It has student ID, gender, and study hours per week, and attendance rate, past exam score, parental education level. Okay. These are education level of their parents, and internet access, at home. And this one is extracurricular activities, and final score, final exam score, and pass fail. Okay, pass. We have to, we are doing supervised machine learning. Wait. Supervised machine learning for binary classification. And we want to predict if the student is pass or fail. Okay. So upload the data set in the Google Drive, or check if you first you have to upload the data set in the Google Drive. Are you following?
Yes, sir.
Yes,
Okay.
sir.
Have you done that? Please let me know if you have done with the uploading.
It's on Google Drive.
Yeah. Tell me if you are facing any issue. Do I need to show you how to upload this?
Done, sir.
Okay.
Done,
And
sir.
others?
Done.
Okay. Now come to the Google Colab. First, you have to mount the Google Drive to the Google Colab. Here you have the Google Drive button. You have to click it, and it will mount the drive. It will ask for connect to Google Drive. Then give the permission, and it will mount it. Yeah. Okay. Where is the drive? Are you following me?
Yes, sir. Done.
Done till here? Okay. And the others?
Done, sir.
Okay. So from here you have the data set.
Yes.
Find the data set. Okay. I have my data set here. So have you located the data set?
Yes, sir.
Okay. So click on the three dots, and here from here you can copy the path. Fine.
Yes, sir.
Just copy the path. Okay. After that, you just keep the path here. We need this in the during the process, during the code. Okay. Till here, everyone done? Do you know programming like Python programming? You know this language, like?
No, sir.
Okay, a little bit, like in the second day, I think.
Yes, sir. Yes, sir.
Yeah.
Yes.
Okay. Okay, that much is fine. Like we don't need much knowledge about Python. Okay, that much knowledge is fine. So after that, you click the code button here. From here, we'll start our program. So you know about libraries, right? First of all, why we use Python programming for machine learning or deep learning, AI, all this. Do you know why we use Python programming for this? Actually, Python programming has lots of libraries, okay, which are very helpful for machine learning. So we use Python programming widely. Fine. So first, we have to import some libraries like pandas, pandas, matplotlibs, and other scikit-learn, this type of libraries. Okay. So follow me. Just do one thing, split your screens using Windows plus left arrow like this, Windows plus left arrow. Fine. Okay. Then you can see my coding and you can follow me. Fine. So import pandas. As PD. Next, we have to write from sklearn. These are libraries, right? Okay. So I am getting some suggestions because I have. Are you getting some suggestions like this?
Yes, sir.
Yes, sir.
Okay, great. So you can just click tab to get this. Okay. So we need this scikit-learn, sklearn, model scaling, print to split. Okay. Standard scaler. We don't need actually standard scaler. We will be going to do min max scaling. Okay. Linear regression. Fine. So label encoder. You're getting these suggestions, right? Okay.
Yes, sir.
Regression, then we will need min max. sklearn dot preprocessing. Oh, sorry. Preprocessing report min-max scalar. Okay. I told about min-max scalar in the session, right? Then we need ROC curve is we need accuracy score for evaluation. Then we need classification report. And we need ROC AOC score, ROC curve, and let's see. Then we need matplotlib. Okay. These are the libraries that we'll need in the program.
Sir, what is after ROC curve?
After ROC curve, AUC.
Okay.
AUC. Okay. Now, is it visible properly?
Yes, sir.
Okay. So these are the libraries that we need. So use shift plus enter. It will run. Okay, shift plus enter, or you can press this sign to run the itself. Okay. After that, the first part was what? We have to load the dataset. Okay. So let us give one comment that load dataset. Okay. So we will use first we will write. Oh, everything is right. It is suggesting everything, right? Okay. So are you getting this type of suggestions? pd.read CSV.
Yes.
PD means panda. Okay.
No, sir.
Pandas. Okay, you are not getting this type of. Okay, fine. So you can just type this pd.read CSV. Fine. So here you have to give this path. Okay. Just copy this and paste here. So this is the path. Your path might be different from mine. So you have to go to the drive. Okay, someone is waiting. Okay. Go to the drive and take out the path. Okay. Next, the data is loaded. Fine. Now you have to do what? The pre-processing part starts from here. So we can take out how many number of rows and columns are there. How we can do that? Like just print dataset shape. Okay. Dataset shape means what is the number of rows and columns are there. It will show that. Dataset shape. DF means data frame. Okay. DF means data frame dot shape. This is a keyword. From here, you can see how many number of rows and columns are there. There are 708 number of rows in the dataset and 10 columns. Okay, out of the 10 columns, one is dependent and other 9 are what? Independent features. So these are the column indexes. We have student ID, gender, okay, study hour, attendance. These are this one pass fail is the dependent feature. We have to predict this, right? Fine. Okay. So the data set is like this. Fine. So now the pre-processing part will be begin. First, we will do what? Now first we will drop the not available, that means empty values. Okay. Missing values, we will drop this. DF means data frame, DF dot DRO, we drop NA. This drop NA is a keyword that used to drop the empty values. Okay, fine. So let us check. Okay, it is executed. Now if we want to check how many number of columns, how many number of rows are there, save. Let's try it. So there are 708. That means the data don't have any missing value. Okay. First we did what? So are you following?
Yes, sir.
Hello? Okay. This much done? This much? Till here?
Yes, sir.
Okay. So it means the dataset don't have any missing values. So that the number of columns is same, 708. Okay, fine. So after that, so there are two classes, pass and fail, right? So we'll do one thing. We'll encode the pass as 1 and fail as 2, or fail as 0. Okay. To do that, oh, sorry. Encode the process. We will use label encoders to encode. Okay. We need to write a for loop so that it will go through all the pass and fail values and encode it accordingly. Okay, if it gets a pass, like then pass will be converted to 1 and fail will be converted to 0. Okay. We generally do this in binary classification. Let's check. Careful. You are doing the coding, right?
Yes, sir.
So wait for a second. I'll do it differently. Here we need a if statement. If colon is not in, colon is not in. This sign is, you know about this sign? Not equal to, okay? This explanation and equal. This colon is not in. Pass fail. Then do what? LE means level encoder, okay? Level encoder. Then data frame. Colon. Oh, transform df colon. Okay. So here, level encoder is a library where we will do the encoding part. Till here, all done till here.
Yes, sir.
Okay. Next we will this statement will encode the levels. Okay, the target encoder called the level encoder. From here, the data frame pass fail. That means the last column, this column, it transform.
Sir, what is
This
the use of encoder?
this is used for encode the levels. Okay, these are the levels, pass fail. Okay, so we have to encode them as 0 and 1. We are trying to do that because it is a binary classification, so it will be easier for the model to understand. Fine.
Okay.
Okay, so this is a label encoder is a library. We called it here. Fine, sklearn preprocessing level encoder, and we are using this level encoder as LE, so that LE, so that it will easier for us to write, and LE fit transform DF column. That means one column is, we are taking one column and fit it in the label encoder here. And after that, we use target encoder. This is a variable, target encoder as level encoder. And we are fitting the this column pass fail for this encoding purpose. Okay. Let's run this. Okay. Now we will apply scaling. Okay. Min max scaling, we'll apply that. Oh, there's an error. Select data type. Okay. Okay. D types. There is a mistake. Please correct it. It will be D types. Okay. Not data types. Fine. Just do this. Are you following?
Done.
Is
Yes,
it
sir.
fine?
Done.
Okay.
Done.
After this, we will apply min max scalar. What will min max scalar do? I have already covered it. So it will do what? It will balance the data set. Okay. So here we will split the data. So I will split the data. X is what? X and Y. I have already covered. What is X?
Sir, X is independent variable.
Yeah.
Y is dependent variable.
Yes, exactly. Very good. So X is independent variable. So we have to drop what? The dependent one, right? As this suggestion, DF drop pass fail. So this is like pass fail is the dependent one. So we have to drop it from X. Fine. Let's just do it. No, it's okay. We will not do this now. Save it for later. So what we'll do, this statement, this first statement, X equal to DF dot drop. DF means data frame. Data frame means this one. We are keeping this data in the this data frame, right? DF. Okay. So entire data set is in the DF. Fine. We have loaded the data in the DF. Okay. So we are manipulating it now, like X is equal to DF dot drop. That means X is a variable, and it will keep what? It will keep the data frame which don't have pass fail column. Okay. Drop means what? It will drop the pass fail from the data frame, entire data frame. Fine. And scalar is another variable which calling this min max scalar. Fine. So X scaled means scalar. X scale means what? It will contain the balanced data set. Fine.
Sir,
Sir,
what is
what
the
is
use
the
of X is equals to 1?
yeah, same question.
X is equal to 1. So this is a one column, right? So that is why we're using X is equal to 1. This pass fail is one column. Fine. Okay. We can do also like before splitting, we can do this min max scalar. It will be also going to be correct. But it's fine. Okay. Next we will do what? Now we'll get the Y, TF. So what will do this statement? What will this statement do? Anyone? Y is equal to TF pass fail. That means
It will pass the independent variable.
yeah, it will capture the dependent variables in the Y. Yeah, right. So after this, we will do print test plate. Okay. So in the train test split, we are splitting this data set into 4 parts. First one is X train, X test, Y train, and Y test. First we did what? We separated the independent and dependent variables. After that, we are doing train test split. Fine. Train test split means we are splitting the X, that is the independent variables. Okay, it is in this test size means it is that I have told that 70-30 ratio, right? So 0.2 means the test size will be 20% of the entire data set. So we'll do it 0.3 so that it can be split in 70-30 ratio. Fine. Are you getting this X test and Y test?
Can you explain that again?
Okay. X train means this is the independent variables, right? We are separated it from the dependent variables. Now we do what? We take 70% for training purpose. We use 70% of the independent variables for training purpose and 30% for test purpose. Fine.
Yes,
This
sir.
much? Okay.
Yes, sir.
So after that, again, we will use 30% of the dependent variables, that is Y, for training purpose, and 30% of the, oh, sorry, I'm telling like 70% of the dependent variables for training purpose and 30% for test purpose. This is like 70-30 and 70-30. Fine.
Yes, sir.
Okay. So this train test split is another library which will take these statements as argument, like X scaled. It will take X scaled. This one is X scaled. Okay. And Y. This is Y. So these are arguments. And test size. Test size means what is the ratio? It will split the data. Fine. 0.3 means 30% of entire data set. 30% of entire data set will go for testing purpose. Okay. For Y test, X test, this splitting will be done in 70-30 manner. And this random state is the data is picked in a random format, and this so that we use random state 42. Fine. We can use any number here, and we can repeat that number if we need the random state, a similar random state. Fine.
So what does it do, random state?
It will pick the columns, pick the rows in a random manner.
Then what does the number 42 do?
Number 42 is like we can use 1, 2, 3, 4 here. Fine. But the state is like if we again do some random sampling there, then if we use 42, then the randomness will be same. It will pick the similar random values. Fine.
Yes, sir.
Okay. Till here, are you following? Like, are you doing this coding?
Yes, sir.
Okay. So now we have to fit this in classifier. So CLF, we are taking this CLF variable as a classifier for classification. And we are using logistic regression, okay? What logistic regression algorithm do? I've told. it will use for classification. It will do the classification. CLF.fit xstring ytrim. Logistic regression is not defined. Okay, I have used linear regression. Okay, fine. We have to use logistic regression here. Okay. Logistic regression. Modeling. Please go to the libraries section. Importing libraries. There you will have to change this linear to logistic. Okay. Have you done that?
Yes, sir.
Yes, sir.
Okay. Just run it again, this section, and it will be CLS. Okay.
That's still showing error.
Yeah, it is not CLS, it's CLF. Yeah. Still saying X string. Okay, this is there is an underscore here. Yeah. Fine. Okay. Done till here. Are you getting any error?
Sir, I am getting an error.
What is saying?
Name error. Name logistic regression is not defined.
Okay, go to the first cell here.
So I have defined there logistic regression.
Okay, you might have not executed it. Just press Shift and Enter, or click this button.
So shall I share my screen?
Okay, you can share. Let me stop. Yeah, share screen.
Is it visible?
Not. Okay, yeah. Yes. Okay, what's it? Okay, go to the first cell. Logistic regression. Okay, click Shift Enter. No. Click on that cell first. Go to the yeah. Okay. Now,
Oh, yes.
yeah. Fine. Yeah, is it visible now? Is it visible?
Yes, sir.
Okay. So we have done till model. This is the model. Logistic regression is the model. We have fitted the model with X train and Y train. Fine. Oh, sorry. So after that, we will do prediction and evaluation. Okay. So till here, the model is fitted to the dataset is fitted to the model. Okay. The dataset is fitted to the model. So after that, we can take out the predictions. Okay. YPRED is used for getting the predictions of X test. Okay. YPRED means what? It will take this test set and tries to predict the outputs from this CLF predict. Okay, CLF predict means CLF has the model, right? CLF has the model and it is loaded with the dataset Xtrain and Ytrain. Now it will do what? It will take X test as for testing. It will take X test data, the 30% data for testing the model. Okay, to predict the outcomes. Fine. Am I clear?
Yes, sir.
Okay. So run this, and after that, we'll do what? We'll check the actual till here, the prediction is done. Okay. If we want to check the actual values and predicted values, we can do this like outcomes. These are comments, okay? Comparison. The actual test predicted. Okay. I think this is correct. EF data frame, actual Y test, predict YPRED. Yeah. Okay. Let's see. So can you see this? Are you able to view?
Yes, sir.
Okay. So these are the actual classes. Okay, we have encoded the fail as 0 and pass as 1, right?
Sir,
So this is
CLF is used for classifying, right?
CLF, right?
Yes.
CLF is a variable. So it is taking the logistic regression algorithm, okay, and it fitted with the dataset, Xtrain and Ytrain dataset. Understand or having any doubt?
Okay, sir.
Okay, that means you are not understanding. Okay, so CLF have this algorithm first. Okay, simple, and it is fitted with the dataset. Fine, simple. Now is it
Yes,
clear?
sir. Yes, sir.
Okay. Okay. If I remove the encoding part, if I remove this encoding part, then let's check what it will print. Fine. Data pre-processing. Data. Okay. Let's skip this. Min-max scaling. Okay. If we not encode the data, then this min-max scaler will not work because it is taking the integer values. Okay. That is the reason we are doing min-max. Fine. Okay. Here, this actual means what? Actual means this actual classes. Okay. Pass, fail, this actual classes. And predicted means the model is predicting these classes as 0, 1, 1, 1. So 0 means fail and 1 means what? Pass. We have already encoded this. Okay. After this, let's do Y probability. Let's find the probability. Okay. Y provides another variable. CLF dot predict. Text. And this is column 1. Okay. It will give the probability. Now we are printing the accuracy and other matrices. Okay. This probability, it will convert the predictions as probability. Okay. Let's complete this. Accuracy. This is for some report. It will generate the entire report for classification. Right. And classification. White, red, white, probably. Sorry, white, red. Prediction. Target means target improvement of fixes. Fine. The first line will do what? Print the accuracy of white test and white bread. That means the accuracy between testing and actual data and the predicted data, okay, by the model. And the classification report have the whitest, widespread, okay, widespread, and target names. So let's see. Target names means target encoder classes. Okay, that means classes. Fine. So here is the ratio that I have already told that. Okay. Okay. Fine. So this is the actual accuracy. Accuracy is how much? The model accuracy is 0.96. If we convert it to percentage, then it will be 96%. Okay. 96%, that means. So the model is correctly able to predict 96%. Fine. And this precision means how much I have told you that this positive class and negative class about. Yeah. Hello.
Yes, sir.
Okay. So this precision means how many positive class are correctly predicted. Okay. Fine. So pass fail equation. 97% fail classes are predicted correctly, and 95% pass classes are predicted correctly. Okay, this is the precision value. This is the recall value. Recall means how many true categories are correctly predicted. Okay, the true categories are predicted over positive class. Fine. These are actually some complex evaluation matrices. So you have to learn it quite elaborately. So this F1 score, this score gives the overall prediction, overall model performance. Okay, so here 96 means 96%. The model is good. It can predict the 96% accuracy. Which okay. After that, we can plot this for AUC ROC curve. So FPR means false positive rate. TPR means true positive rate. Okay. This will generate a curve, generate a graph, so that we can visualize the performance of this algorithm. Fine, performance of this entire model. So do you having any doubt? Anyone?
No, sir.
Okay. You see ROC curve. TPR, FPR can be calculated from this performance matrix. Okay. We are not calculating it here. This we call this some libraries here, right? For classification report, ROC, AUC ROC curve. So in the libraries, there are a lot of mathematical functions are there, and does this FPR and TPR, these are calculated. Okay, so let's plot this. Figure size. Figure size is 8 by 6. Fine. Okay. 8 by 6. So this figure size will create a graph create a graph of 8 by 6, 8 centimeter and 6 centimeter. Okay, 8 into 6. So let's just yeah. Whatever. Okay. Let's take the color as blue. Level false vertical to vertical. Okay, fine. Let's run this. So here you can see are you done with this part?
Yes, sir.
Okay. So from here you can see the ROC curve. That means it will show how the model predicting how good is the model and how good it is in predicting the classes. Okay, it is 96%, right? It is 96% accuracy, and the overall uh, model performance is also 96. So here we can see this is not completely 1. If it is 100%, then the curve will go till here. Okay, till this 1, and it will be a perfect model. Okay, so this is not random classifier. Okay, so you can visualize your entire model through ROC curves. Fine. These ROC curves are generated through true positive rate and false positive rate. Here, the true positive rates are here, and the false positive rates are here. There are formulas, obviously, for calculating true positive rates and false positive rates, but this is not like we have to go very deep to understand this everything in the true positive rate and false positive rate. You can explore it by yourself. Okay, I can give you the formula for like true positive rate is true positive by true positive plus false negative. This is the formula for true positive rates. Okay, and similarly, false positive rate has a formula, but you have to know the entire performance metrics. Okay, so I will suggest you to explore this performance metrics formulas. Okay, so here the first program is done. Okay, so do you have any doubt? Are we able to get this? Anyone?
Yes, sir, it's done.
Done. Okay. So you are getting similar kind of ROC curve.
Yes.
Okay. So you can use another data sets. Okay, different data sets to perform this binary classification. Fine. There are two more codes are there, but we have less amount of time. So do you have any doubt in any part of this program? Or anyone having any doubt? Okay, then. Fine, you will have one this kind of programming in the assessment part. It will be a small program. Okay, no need to worry. So try to explore it, this supervised machine learning more. Okay, thank you for now. We'll meet again tomorrow. Thank you, everyone. You can leave now. Fine.
Thank you, sir.
Thank you, sir.
Okay.
Use